Hello, we're going to continue on part two on the Calculus 1 final exam derivative section. So there's only a few more left and it's just word problems. So let's go over both of those. So we stopped off on 21. So a balloon is being filled with helium at the rate of 4 feet cubed per minute. The rate in square feet per minute at which the surface area is increasing, the volume is 32 pi over 3 feet cubed is. So what are they asking? The rate in square feet per minute in which the surface area is increasing when the volume is 32 pi over 3 feet cubed. So imagine being a balloon and it's slowly being filled with helium, so it's getting larger, right? So maybe we should draw a little image. So here you have a balloon, right? And they're asking what the rate in square feet. So they're asking for a rate in square feet per minute in which the surface area is increasing when the volume is this. So they give us that. What did they give us? They give us a rate. They give us dV dt, excuse me, which is 4. And what we're trying to find is, well, they tell us that volume is, let me write that down. Volume is 32 pi over 3. And what we need to do is find the rate, the rate in which square feet per minute at which the surface area is increasing when the volume is 32 pi over 3. So I believe they're trying to find dSA over dt. That's what they're trying to find. So yeah, what formulas do we need? I believe since we're talking about volume and surface area, um, those, well, we know the volume is, this, I think this is considered a sphere. A balloon is technically a sphere, right? So the volume of a sphere is 4/3 pi r cubed. And what is the surface area sphere? It is going to be 4 pi r squared. So these two formulas will come in handy. So what we're going to do is, if we're trying to find DSA, the surface area in respect to time, that's what they're asking, the surface area in respect to time. Um, Now, do you think this is a increasing? Yeah, it should increase. It should be kind of fairly large because when you're filling helium in a balloon, it's slowly increasing. So yeah, so what I'm gonna do first is, so I have these two formulas, right? These are gonna be very helpful. We're probably gonna use this, and we're probably gonna do implicit differentiation in order to find the surface area in respect to time, right? So what I would do first is probably I'm gonna find r squared. I mean r. So step one, I'm gonna find r. And how do I do this? What formula shall we use? Uh, we're gonna use this form, the volume formula. So volume equals 4 pi r cubed over 3. How on earth are we gonna find the r? Well, they did give us a volume, which is 32 pi over 3. And then this is 4 pi cubed. So let's solve for r. So what can we do? What about 32? Does 32 over 3 come out nicely? Um, Not quite. Let's see. Volume equals 4 pi. Oh, I know. The threes cancels because if you multiply both sides by 3, they cancel. So you have 4 pi r cubed, and then over here the threes cancel, so you're left with 32 pi. What else cancels? It looks like the pi's, right? So you have 32 equals to 4 r cubed. And then maybe we could divide everything by 4. So 32 divided by 4 is 8. And then you're going to solve for r by raising both sides by the reciprocal of 3. Or you can take the cube root of r. I'm just going to raise everything to the 1/3. Get it? So this cancels. And then what's 8 to the 1/3? 2. So my radius is 2. Okay. Okay, so if my radius is 2, we have to find r. So what would be the second step in order to find SA, uh, dSA over dt? I'm going to find dr dt. So step 2, I'm going to find dr dt. So, how do I do that? Well, what we're going to do is use the same volume formula. V equals 4 pi r, oops, 4 pi r over 3, right? That's what we're going to do. And then what we're going to do is just take the implicit differentiation in respect to time. So over here, this would be dv dt. Over here, this would be, so how do you take the derivative of 4 pi? Sorry, it's v equals 4 pi r cubed over 3. So yeah, how do you, so I took the derivative of v in respect to time, so I got dv dt. What about this? 4 pi r cubed over 3. Um, you could just use the power rule. So what's 3? Wait, yeah, 3 times 4 is 12. Yes. So take over for this side. To take the derivative, you use power rule. So what's 3 times 4/3? That is, well, 4 times 3 is 12 divided by 3, which is 4. Yeah, 4 pi r and then squared, because whole power minus 2. And then you have to add dr dt. Okay. Okay. What to do next? So our goal is to find dr dt. So I have to get rid of this. Let's just fill in what we know. Do we know what dv dt is? Yes, that was given. The rate is 4 feet cubed per minute. So you could just say replace this with 4. And do we have a radius? Was that given? Yes, we just found it in step one, which is 2. So we're gonna replace this r with 2 square, and then you have dr dt. Okay, clean this up. 2 square is 4 times by 4. That's 16 pi. Right? 2 square is 4 times by 4 is 16 pi dr dt. And then you have 4 here. And then go ahead and solve for dr dt. So all I gotta do is divide both sides by 16 pi. So that gives me dr dt. And then 4 over 16 can be reduced by 1, and then 16 divided by 4 is 4. So that is 1/4 pi. So I have my dr dt. I'm going to box it. It's not our answer, right? We still got to find dsa dt. So how do you find ds dt on it? Oh, we found it. Uh, okay, so yeah, I forgot this formula. So the other formula we had to use was surface area. So what is surface area? Surface area is of a cylinder is 4 pi r square. And then you just do the implicit differentiation. So this is going to be dsa dt equals, and then you just use how do you take the derivative of 4 pi r square? Power rule, right? So 2 times 4 is 8 pi, and then 2 minus 1 is 1. And then in respect to time, you do have to add that dr dt, which we found, which is 1 over 4 pi. So all you got to do is fill in the blanks. So you have dsa dt equals to 8 pi, and then dr dt is going to be 1 over 4 pi. And 8 pi times 1 is 8 pi. 1 times 4 pi is 4 pi. And that just becomes 2, right? Oh, my bad. What's the what is the derivative of 4 pi r squared? It's 2 times 4 is 8 pi, and then I forgot you have that r. So that's why I was off. It should be so dsa dt is going to be this 8 pi times my radius, which was found, which is 2, times it by dr dt, which we also found that that's going to be 1 over 4 pi. So when you put it all together, the pi cancels. 8 times 2 is 16, divided by 4 is 4. Three. Okay, let's move on to 22 then. Okay, so um, water is being poured into a conical reservoir at the rate of pi cubic feet per second. The reservoir has a radius of 6 feet across the top and a height of 12 feet. At what rate is the depth of the water increasing when the depth is 6 feet? So imagine having some kind of cylinder and pouring water in that cylinder. So we can draw an image. So yeah, so imagine s- s- and they tell us that it has a radius of 6 feet. What else? So what are we trying to find? Um, at what rate is the depth of the water increasing when the depth is 6 feet? So they tell us that, oh, they also tell us that the height right here is 12 feet. So that's important. So you can write that down. Height is 12 feet. So my radius is 6 feet. My height is 12. Um, and then they also give us speed, dv dt. Do they? Yes. They tell us, yes, they tell us that we have a speed of dh dt. Um, so dv dt is what we're trying to find, and they give us one rate, which is sorry, no. dv dt is given, and that is pi. What we're trying to find is dh dt, right? That is what we're trying to find. So how do we do this? So if we're dealing with um a cone, and I think what we're trying to find is, I think we're gonna have to use the volume formula of a cone. So, or of a, yeah, of a cone. So what is the volume of a cone? It is gonna be V equals 1/3 pi r squared times h. Okay. Um, do we have a radius? Not quite. You could you could think of it, the reason why, wait, you see, it's slowly increasing. So the radius is not 6 anymore. It's like it's not. So what you do is you kind of set it up as a ratio. So it's going to be, we'll set it up as radius over height ratio. So it was originally given that the radius is 6 and then the height was 12. And so you could say R over H equals 6 over 12. Yeah, so this is changing. That's why we can't really use the radius as 6 because it's changing. So what you would do is cross multiply. So our goal is to solve for R. So what's 12 times R is 12R H, and then equals 6 times H is 6H. Go ahead and solve for R. So you're going to divide this by 12. And you get 6 over 12, which is 1 over 6 over 12 could be reduced by 6, which is 1 over 2 H. So radius is 1/2 H. So we'll put it in this formula. Um, wait, why are we doing this? Why are we putting R in this? I think what we need to do is find, yeah, let's just put that in the formula. And I don't know why. I want to see what happens. So when we put that in, this R into this, oh, I know why. Because we have to put it in terms of h, right? So if our new radius is 1/2 h, this will come up really nice. So it's going to be 1/3 I, and then we're going to replace r with 1h over 2 squared times by h. You get v equals h squared times h is h cubed. And then you have 1 over, and then 1/2 squared is 1/4 times it by 1/3, 1/3 pi. Okay, so now what we're going to do is we're going to take this in respect to time, implicit differentiation. So what's that going to be? So the derivative v in respect to time would be dv dt, and you get, so go ahead and do this. If you want, you can say this is going to be pi h cubed over 12, right? And then how do you take a derivative of this? Use power rule. So 3 times 1 is 3. So yeah, 3 times 1 is 3 divided by 12. That's going to be 3 pi h squared over 12. And then 3 over 12 can be reduced by 3. So this is 1. 12 divided by 3 is 4. So you get uh, pi h squared over 4. And then if we're taking it in respect to time, you do have to add this dh dt. Okay, so that's our goal. We're almost there. So now we just got to fill in the blanks. So do we have a dv dt? Yes, that was given. That was given as pi. Do we have a height? Um, yes, the height was, well, remember, we were given that radius is 1/2 times h, and so I think you can replace, if you want to solve for height, my radius was originally given was as 6. Um, oh, yes, now I remember. Okay, yeah, the height, the new height is 6. Okay, so if you go back to the problem, it says, what is the rate when the depth of the water is increasing when the depth is 6 feet? So that's our new height. I was like so confused, like how did they get 6? Because that was given. So yeah, so dv dt is pi, and then it's going to be pi, and then our new height from the word problem is 6 squared over 4, and then you have dh dt. Okay, so clean this up a bit, and you get 6 squares 36 pi over 4, and then you have dH dt, and then you have pi, and I believed 36 over 9, 36 over 4 is 9 pi, dH dt, and then you have pi here, and then you go ahead and get rid of this pi. So you have dH dt. Oh, why? I have to get rid of this 9 pi, sorry. Wow. So get rid of this 9 pi by dividing both sides by 9 pi. There we go. So the pi's cancel, so now you're left with dH and dt. This is a 1 here, so that's going to be 1/8. Okay, so dH dt is 1/8, and that was their, that's what they wanted. Okay, last one for this section. Okay, so this one says the length of the sides of a square are decreasing at a constant rate of 4 feet per minute in terms of the per meter p. What is the rate of the change of the area of the square in square feet per minute? So they're asking you, what is the rate of the change of the area of the square in square feet per minute? So let's pretend you have a square, and in a square, all of the sides are the same, or you can say all the sides of the length are x's, right? Okay, so you have a square, and all the sides are x's. And what else do we know? It tells us speed. It says the length of the sides, the length of the sides of a square are decreasing. Okay, so this square is decreasing at a rate of 4 feet per minute. So that is the speed, and that is a dx dt. And since it's decreasing, it's going to be negative 4 feet per minute, right? What do, they're asking what is the rate? So we need to find dA dt, right? So what formula shall we use? Well, we can find the area of a square, and we can also find the perimeter of a square, right? So the area of a square is like basically length times width. So each side is x, so it's going to be x times x, which is x squared. And then a perimeter is used to add up all the sides, which is you add up all the sides, 1x plus 1x plus 1x plus 1x is 4x. And our goal is to find dA dt, a dt. So I think we're going to use the area formula first. So what's the derivative of this in respect to time? So that's be dA dt. And what about the right side? What's the derivative of x squared in respect to time? Well, the derivative of x squared is 2x, and then you do have to add that dx dt. Okay. And then over here, per meter, I have a feeling I might want to solve for x. So if you look at per meter equals 4x, basically we just add up all the sides. That's how I got p equals 4x. I want to solve for x because I feel like I'm gonna have to put that back into here because you have an x here, right? We don't have a p, so let's solve for x. So divide this by 4, divide this by 4, and you get x equals p over 4. Okay, so I'm gonna put that in this formula right here. So it's gonna be dA dt equals 2, and then times by x, which is p over 4, times it by dx dt. That is something, that's the speed we have, right? We're trying to find dA dt, that's our goal. So that was given as -4. So when you put it all together, this cancels, you're left with negative 2p, uh, dA dt, which equals to negative 2p. And that is your answer. Okay, yeah, that was kind of shorter than the first one because I finished most of it on the first video, so I'm gonna stop here.